Okay, we'll start in on section 3.3 here. So we're going to talk about graphs of polynomial functions. The first four sections that I'm going to talk about here, 3.3 through 3.6, those are going to be about polynomials. So polynomial, that's a really important topic here that we have to know. There's a definition. It says that if f is a polynomial function and k is a number for which f of k is 0, then k is called the 0 of f, or a root of f. It's the same thing. A 0 and a root mean the same thing. Also, if k is a 0 of f, then x minus k is a factor of f. Okay, you guys are going to be doing lots of factoring coming up here. Okay, so whenever you know a 0, you know a factor. All right, so let's try this example. I want us to check if k equals 2 and k equals -5 are zeros for the polynomial f of x equals x cubed plus x squared minus 17x plus 15. Okay, well, so I need to be a 0, I need to plug in the number and it's going to return 0. Okay, so if I plug in 2 here, 2 cubed is 8, plus 2 squared is 4, so 8 plus 4 is 12, minus 34 is -22. -22 plus 15 is -7. So I'm not getting a 0 in return. Okay, so that means that 2 is not a 0 of f. Okay, and now I want to know if -5 is a 0 of f. Well, same deal. So I'm going to plug in that number and simplify this. So -5 cubed, -5 times -5 times -5, that's be -125, plus 25 is -100. -17 times -5 is 85. Okay, so I'm looking at -100 plus 85, that's -15. Plus 15, that gives me 0. Okay, so -5 is a 0 of f, and therefore x minus -5, or x plus 5, would be a factor of f. Okay, x minus 2 is not a factor because 2 is not a 0 of f. All right. Let's take a look at this next one here. So we want to find a polynomial of degree 3 whose zeros are -1, 1, and 3. Okay, a polynomial function is a function where you're adding up a bunch of things, right? And there's two things that you're looking for. So the first thing is that every single coefficient has to be a real number, and every single power of x has to be a whole number. Okay, so let's see. Well, I want to find a degree 3 polynomial. So the degree is always the highest power of x that appears, whose zeros are -1, 1, and 3. Okay, so knowing that these three numbers are zeros means that I'm going to know three factors. If k is a 0 of f, then x minus k is a factor of f. Well, that means that if I call this function f of x, x minus -1, the same as x plus 1, times x minus 1 times x minus 3. Okay, now this is not written in polynomial form, so we're going to need to write it in polynomial form where I'm adding up a bunch of terms there. Okay, well, if I FOIL this out, x plus 1 times x minus 1, that's x squared minus 1, and then times x minus 3. If I FOIL this out again, I have x squared times x is x cubed, and then minus 3x squared minus x negative 1 times negative 3 is plus 3 at the end. Okay, so there's my degree 3 polynomial. Okay, the highest power of x is 3. And this is in polynomial form, right? So I'm adding up some terms there. Also, the two conditions are satisfied. You know, the first condition, so every single value in front of x is a real number. So 1, negative 3, negative 1, and 3, those are real numbers. And also every single power of x is a whole number. Okay, well 3, 2, and 1, those are whole numbers. A whole number is a counting number that is 0 or bigger. So 0, 1, 2, 3, 4, those are whole numbers. Okay, now another polynomial could be this guy. So what if I had the 3 zeros, the 3 factors? Now there wouldn't be any problem with me throwing a number in front, you know, as long as that number is not 0, because 0 times anything is 0. And I'm supposed to find a degree 3 polynomial, not a polynomial with no degree. Okay, so if I take this answer here that's circled, and then I multiply by 5 on these 4 terms, another polynomial could be 5x cubed minus 15x squared minus 5x plus 15. In fact, there's infinitely many answers to this. Any polynomial of the form f of x equals a times x plus 1 times x minus 1 times x minus 3 will work, where a is some real number. A can't be 0 again. Okay, now suppose that we wanted to find a polynomial of degree 3 whose zeros are negative 1, 1, and 3. And suppose also that we're told that f of 3 is 6. Okay? By them telling me that information, that means that there's only going to be one answer, not infinitely many answers. There's going to be one answer. And by the way, you know, in these situations, like, it's going to be most convenient for us to just let the a value be 1, although a can be any number. Okay? But f of 2 is 6. Okay, well, I'm going to start by using this form, f of x equals a times x plus 1 times x minus 1 times x minus 3. F of 2 is 6. So f of 2 means that where I see x and f, I'm going to replace that with 2. Okay, so I got a times 2 plus 1 times 2 minus 1 times 2 minus 3. That'd be a times 3 times 1 times negative 1 is negative 3a. F of 2 is 6. So negative 3a equals 6. If I divide both sides by negative 3, a is negative 2. Okay, so the specific polynomial that we're looking for is negative 2 times x plus 1 times x minus 1 times x minus 3. And if I distribute negative 2 into these terms there, I'll have negative 2x cubed. It's going to be plus 6x squared plus 2x minus 6. Again, that would be the answer. Now, that's the only answer that there would be if they told me the f of 2 is 6. Okay. Now, if a factor occurs more than one time, then its zero is called a zero of multiplicity. So here's an example. What if I had the function f of x equals 3 times x minus 4 times x plus 1 squared times x minus 2 to the 4th? And I want us to find the zeros of f. Well, a zero is a number that I can plug into the function and it's going to return 0. So 4 would be a 0, right? Because 4 minus 4 is 0. Now 4 is a 0 that has multiplicity 1 because its 0 is only seen one time, or its factor is only seen one time. Negative 1 would be another 0, right? Because negative 1 plus 1 is 0. Negative 1 would be a 0 that has multiplicity 2 because I see the factor 2 times. And then 2 would be another 0. 2 minus 2 is 0. And 2 is a 0 of multiplicity 4. So all I'm doing to get the multiplicities is I'm looking at the exponents, right? By the way, the 3 has nothing to do with anything. That's what I was just talking about over here. So a can be any number, right? That's not important to us. Now, something to note here, this is a polynomial. It's not written in polynomial form, but I can write it in polynomial form if I wanted to, where I expand it all out. And the degree would be a degree 7 polynomial. So there would be 7 zeros, not 3 zeros. Okay? I have 3 zeros listed, but some of those zeros repeat. Okay, so -1 repeats 2 times, 2 repeats 4 times. 4 only repeats 1 time. Okay. The next thing is even and odd multiplicity. Okay, it says let x minus r be a factor of a polynomial function f of x. If n is an odd number, then the graph is going to cross the x-axis at r0. And if n is an even number, then the graph is going to touch the x-axis at r0. So think of just a really easy example. Think of y equals x squared. That parabola comes down, touches the x-axis, and pulls away type thing. Well, that's because the degree is 2, and 2 is an even number. Okay, if I had y equals x cubed, that graph is in quadrants 1 and 3, and comes down, crosses through the origin, or the x-axis, and then heads downward into quadrant 3. Well, the reason why that happened is because n is an odd number, right? N would be 3. Okay, so let's take a look at this problem next. What if we had the function f of x equals 4 times x plus 4 squared times x minus 3 cubed? Well, the graph is going to touch the x-axis at the point 4, 0, or -4, 0, okay? And because the power is a -2, okay? And that's an even number, okay? And then also the graph is going to cross the x-axis at 3, 0, right? 3 is the 0 of this guy, and the exponent is 3. So let's see, just a second here. All right. So that can be helpful, when it comes to drawing a picture. If I'm drawing a picture and I need to know, does the curve cross or touch the x-axis, I can look at the degree, okay, or the highest power of x. Okay. Let's take a look at these two examples next. So they want us to write a formula for each graph. Okay, so what if I have a graph that does something like that? Okay, well, there's going to be 3 zeros. A 0 is the same thing as an x-intercept. So there's 1, 2, 3 x-intercepts. That means that the degree is going to be a degree 3 polynomial. Okay, whenever I know a 0, I know a factor. Okay, so it looks like the zeros are -3, -1, and 2. Knowing that -3 is a 0 means that x minus -3 or x plus 3 would be a factor. Knowing that -1 is a 0 means that x minus a -1 or x plus 1 would be a factor. And then knowing that 2 is a 0 means that x minus 2 is a factor. Okay, and then a can be any number here. So we'll have to find the specific polynomial that matches this graph. Well, this graph is crossing through the y-axis at 0, -2. So if I let x be 0, let's see, I'm going to have a times 3 times 1 times negative 2. That'd be negative 6a. Now f of 0 is negative 2, right? Because the point 0, negative 2 is on the graph. So I have the equation negative 2 equals negative 6a. And if I divide both sides by negative 6, a would be negative 2 over negative 6, or 1/3. Okay, so my answer would be this guy. F of x equals 1/3 times x plus 3 times x plus 1 times x minus 2. Go ahead and circle that. Okay. Let's take a look at part B here. So what if I have this curve? I want us to find a formula for that. Well, okay, so there's going to be 4 zeros. Okay. Because, so one of the things that we talk about in section 3.1 is the turning points. So if f is a polynomial function of degree n, then there's going to be at most n minus 1 turning points. Okay, so it looks like there's 1 turn, 2 turns, 3 turns. Well, so this function has 3 turns. That means I'm going to have a degree 4 polynomial. Okay, so let's see. I'm going to have f of x equals a times, the zeros are negative 4, negative 2, 3, and then 3 again. Okay, so let's see. Well, knowing that negative 4 is a 0 means that x minus negative 4 is going to be a factor, or x plus 4 is a factor. Knowing that negative 2 is a 0 means that x minus a negative 2 is a factor, x plus 2 is a factor. And then knowing that 3 is a 0 means that x minus 3 is a factor. Now, I got x minus 3 squared. Well, the reason why I have that is because n is even means that the graph of f is going to cross the is going to touch the x-axis at the point r0. Okay, so because we come down, touch, and pull away type thing, I know I'm going to have a degree 2 part there. Okay, now in all, my answer is going to be a degree 4 polynomial. Right? 2 plus 1 plus 1, that's 4. And because there's 3 turns. Okay, now if I find the a value here next, well, the point 0, 3 is on the graph. Okay, so f of 0 means plug in 0 for x. I got a times 4 times 2 times negative 3 squared. That'd be 8 times 9 is 54. Let's see. So then the next thing is, 8 times 9 is 72. Sorry. Yeah, 72. Okay. So we got, it should be 72a equals 3. F of 0 is 3. 0, 3 is on the graph. So 3 would be equal to 72a. If we divide by 72, 3 divided by 72 is going to be 1 over 24. Okay, so I have 1 over 18. It should be 1 over 24. So my answer is going to be f of x equals 1 over 24 times x plus 4 times x plus 2 times x minus 3 squared. And then go ahead and circle that. Okay, well, we'll go ahead and stop the video right here, and I'll pick up with these examples next. And we'll probably finish up 3.3 in the next video there.